Hi there. Today we're going to be talking about means again. So we're going to be looking at two sample means. All right, so the first type we're going to talk about is the independent samples t-test. All right, so in the past, the situation was we had a population. And then we didn't know what mu was. And so we take a sample and we use that sample to tell us something about mu. But here, this time, we're going to have two populations. I'm going to have population 1 and population 2. And then here I'm going to have mu 1, which is the mean of this population, and then a mu 2, which is the mean of this population. And so in either case, I don't know what those are. And but I want to be able to compare the mean of this population to this population, right? So in two sample inference, it's not so much that I want to know what the mean of this population is, but I want to know how different is mu 1 than mu 2, all right? So my inference that we're going to do is going to be on the difference between these two. All right, so for an example, let's say this is the time that men spend working out. So this is a population of men's times at the gym or working out anywhere, I guess. And here's the times that women work out. All right. So how do I know how different? So I want to know what's the difference between, on average, how much more men spend than women at the gym. So how do I know what that difference is? So what I do is I'm going to take a random sample from this guy, sample 1. So I'll take a sample of, try to take a good sample of men and how long they work out. And so this will have, I have N1 men in it. And then I will, and then I'll look at the mean time that the men work out. So here's Y1 bar, and I'll have S1, which is the spread of those men's times. And then I come over here, I'm going to take a sample of women, a good sample, an unbiased sample, and I'll have N2 women. So this will be the number of women in my sample. And I'll have the mean time that those women work out and the standard deviation, my measure of how spread out those times are. And so I'm going to do inference on the difference, right? So what I'm going to look on, what I will use is to estimate this difference. So if I want to know what a confidence interval for the difference in the means, okay, so since I'm calling men's times 1 and women's times. So this mu1 minus mu2, this would be how much more men work out than average than women. It can be negative. Maybe women work out more than men. It doesn't have to be positive. But this is going to be based on the difference in the two samples. So I've got a Y1 bar, which is a good estimate for mu1, and a Y2 bar, which is a good estimate for mu2. And I'll use this, and then I'll, when we get our confidence interval, we'll add them arbitrator. And then I can test. I can do a test for mu1. So if maybe test, maybe I don't so much care how different they are, but I want to know if they're different. So if, women or men work out more, so does the average man or average woman work out more? All right, so basically, is mu1 bigger than mu2, or is mu2 bigger than big 1? So I can do those using this Y1 bar and Y2 bar. Okay, so what makes this independent? All right, so the independent samples is this. I'm going to type this. All right, so independent samples, basically, when we're looking at these men over here, they are unrelated to these women. Remember we talked about independence, that if I had a sample even if I look at my sample here, these men, these N1 men, maybe there's 50 men, that we want these 50 men to be unrelated to each other. And we look at this sample, the women, we want let's say there's, 62 women, my sample, these 62 women to be independent of each other. Well, now I want these men also to be independent of these women. So I don't want any of the times that any of these men work out to be related to any of the times that these women work out. So I don't want them to know each other. I want them to be that all the men over here are independent of all the women. All right. So basically, so what does this mean? All right, so basically the outcome of any observation in my first sample, we don't want it to affect, doesn't affect the likelihood of any observation in the second sample. So for the men above, this would mean that, none of the men are related to any of the women. All right, so I shouldn't get them from the same gym. I shouldn't get them from the same city or whatever I'm going to do with those. Okay, so I want them to be the same way that the men are independent of each other. I want all the men to be independent of the women. So really what I'm going to have here is I will have, so my total number of observations, I will have, N1 and N2 plus, there's my total number of observations. Well, all of those will be independent of each other. Okay, and so the types of inference that we talked about, mu1 minus mu2, the difference in the average. All right, so if we did a confidence interval, we would have for this mu1 minus mu2, say I'm 95% confident that men spend between blank and blank more minutes per week working out. So I would come up with this lower and upper limit, but the limit, my confidence interval would be for the difference in the means, not for the actual mean time they work out. And I could test if they're different. So if the p-value is less than 0.05, that means we prove the inequality. So if the p-value is less than 0.05, we have enough evidence that the average men's time is different than the average women's time. Okay. The other type of test is a pair t-test. And its setup is a little bit different, okay, as opposed to having two totally separate populations. What I have one population. So here's my population. And then within this population, I have two measurements per unit, okay? Two quantitative variables. So I'm going to have two measures, like, I'll give you an example of that. Per person or per unit, whatever a unit is. All right, so what does that mean? So let's get an example. Let's say instead of looking at independent men and women, now we're going to look at dependent. So this pair T is these are dependent samples. All right. So maybe my population is not a man or a woman, but it is a married couple. All right. So each unit in here is a couple. And here's one couple, here's another couple, here's another couple. All right. So all of my population is made up of couples, but within each couple, I have two different times. So I have a time for the husband. And I have the time for the wife. Right? they are not independent of each other. These are dependent. So the amount of time that a husband works out is going to be related to the amount of time that a wife works out. And what does dependent mean? It means that the observation, that if I know the time for the husband, that will affect the probability or the distribution of the time for the wife. So I'm not saying they're going to equal, but they might be closer together on average than a random couple. But because they know each other, these are not independent. Right? So I have two measurements per unit. And so here, if I look at that, I can take this time for the husband, I could subtract out, so put a little minus there, time for the husband minus the time for the wife. That would be how much more the husband works out than the wife. Now, if that was negative, that would just mean the wife worked out more than the husband on average. All right, or the wife worked, if it's negative, this particular wife worked out more than her husband. So what we're looking at here, the average of all those differences. So this is just one couple. But if I look at the whole population, there's going to be this mu d, or mu d. This is the mean time difference for all the couples, for all couples. Whatever these couples are, U.S. couples or Kentucky, whatever they are, right? So mu d, so it's the mean. So they put a little d on here to let you know it's for the difference. It's not. So if I knew mu d, I would have no idea what the average time that the husbands work out. All right, this would just tell me how much more men work out, or the husbands work out than the wives. All right, so how do I don't know what that is. So this mu d, this is a big question mark. So what do? I take a sample of couples. Married couples, all right? And so I would have n married couples. And that's going to be my number of, and by the way, a pair is a twosome. You get a pair of shoes, two. So these are pairs. This time for husband and the time for wife, that's a pair of measurements per couple. I'm going to have n pairs of data. So I'm going to have n times 2 observations. And then I'll have this d bar is going to be the mean difference of the n couples. And then SD will be the spread of those differences. So d bar, this is the mean difference in times. Right, for the n couples in the sample. And SD, this measures the spread of those difference in times. All right, so what's the meaning of a paired sample? All right, basically, we have two dependent observations per unit, right? And the unit above was the couple, right? So a unit can be a person. I might have 2 scores for a person. So I have their score on exam 1, there's a score on exam 2. So my unit is the person. So I've got here, Joe Smith, he got an 80 on the first test and a 90 on the second test. So those 2 test scores are not independent because it's the same student. And so basically, in the same spirit as we talked about before up here, right, that the outcome of any observation in my first sample doesn't affect the likelihood of any observation in the second sample. That was what we had for independent. Up here, for a paired sample, type this in, is that the outcome of each observation in the first column, okay, this is in my data, so I'm going to have 2 columns of data, that this does affect the likelihood of the observation that's in the same row as the second column of data. Right. So each row in your data set is the unit that I'm referring to, and has, and each unit has 2 measures or 2 quantitative variables, all right? So it might be, again, we have the couple is the unit, and they have, some sort of measurement for the husband, and then we have, time for husband, time for wife. That's one example, all right? Another might be that I have each row is a student. So that's my unit, and then I have their first, score, then their second score. All right, and there's there's a million of them. Okay. All right. So when I do inference on a pair T, it's going to be for this mu D, which again, this mu D, this is the mean of all the differences. In the population. All right. And I will use D bar, to estimate what it is. So if I do a confidence interval, I'm going to estimate the difference. I'm not estimating the mean time. I'm not estimating the time for the husband and the time for the wife. I wouldn't be estimating the student's score on the exam, but how much better they did on the second one than the first one. So I do the second score minus the first one. So, and so the confidence interval would say, well, with 95% confidence, husband spends between, whatever this lower limit and upper limit of my interval, more minutes per week working out than their wives. And then if I do a task, my task is going to be, so is there a difference in times? All right. So maybe husbands and wives work out the same amount. Maybe they, so we would just want to test whether they work out a different amount of time. So then if that was the case, if the p-value is less than 0.05, we have enough evidence that husbands spend more time on average working out than wives. All right, so, all right, so let's just do another couple examples trying to figure out what's what, all right? So here's some examples, and we're going to determine whether these are independent or paired. All right, the first one, I take 2 random samples, one in men and one in women, and I compare their time spent doing cardio. Well, this is pretty much the same example. So hopefully you know what this one is. All right, so is this independent? So are the men and women, are they independent of each other, or are they pairs of observation? Right? And here the idea is if they're independent, can I hook up one guy? So is there a person in my random sample of men that goes only with one woman? Or is there only one woman over here that's related to this one guy? And that answer is no. This is a random sample of men, a random sample of women. They're unrelated to each other. So there isn't a relationship between these men and these women. So this is going to be independent. And here we'll do an independent T. These are T tests, by the way. Independent T interval or an independent T test to see if there's a difference in time spent doing cardio. Husbands and wives, those are related. So if the people in the first sample and the people in the second sample are related to each other, then we're going to do a paired T. We will do a paired t-test or a paired t-interval. All right, so here's another example. Let's say I assign half of a bunch of subjects. So I have all these people, half of them, I say, you go do this workout. And the other half of the subjects, I say, go do another workout. And then I'm going to compare their increase in strength. I'm going to have them do lift some bar, do some lifts. All right. And I compare how much they did before to how much they do after. All right. So here's the thing. Are the subjects that do this workout, are they related to the subjects who do the second workout? Mm-hmm. And the answer should be no. All right. So I have 20 people in my study. I picked 10 of them to do the first workout 10. So these are different people. And they're not paired up. I didn't say here's, a husband and wife, or here's this person. I didn't match these up together. All right. So this is going to be an independent T. By the way, what kind of study is this? What kind of data is this? And I should put here that I should randomly assign these. So if I do have 20 people, I should randomly assign 10 of them to do the first workout, another 10 to do the second workout. Okay. So since I'm assigning them to the workout as opposed to just observing what workouts they were already doing, this is an experiment. Which means when I get to the end of the study, if the increase in strength for one of the workouts is significantly more than the other, then I would say, it's the workout that's causing the difference in increase in strength. So I could associate cause with that. Okay, so that's independent. What if I have a person do one type of workout for 1 month, and then they do the other workout for the other month, for a second month, an increase in strength? I've got the first workout and the second workout. Are these people related? Are the people who do the first workout related to the people who do the second workout? Yes, they're related. They're the same person. We are related to ourselves. All right. So the same person does both workouts. So I've got 2 measurements per person. All right. So this is a paired T, either a paired T test or a paired T interval, depending on whether I want to estimate the difference in the increase in strength, or if I want to just test if the workouts are significantly different from one another. Okay. All right. So that is 2 sampled t-tests, either independent T or paired T, comparing the means between 2 groups. Okay, that's it for today. Thank you. Have a nice day.